Hello everybody, welcome back. My name is Bill Oliver and this is my channel, Boston Devops Bill, and what we're going to do today is we're going to put to rest the IP sync system. So there's a couple of things which we need to do before we can do that. First of all, we want to go in and remove the temp file after it's created so that it doesn't fill up our temp directory. We also want to remove a log message, which is actually written into the logs every time we execute that. So we want to clean that up. We don't want our logs filling up with useless messages. We only want error messages in our logs. And third, we need to add ourselves to the proper group in order to access the share without root. So we'll be doing that. And then, here comes the big then, we're going to add another subsystem to our provisioning system. Okay, so as we describe our nodes inside of a JSON, we're going to put in what type of disk storage we're going to require. And that's going to be read by the provisioning script. And then it's going to actually create that using the script which we're about to create, okay? And we call that script VM add disk. VM add disk is going to be called from our Vagrant file, and it's going to take three parameters. It's going to take the size of the drive we want to create. It's going to take the type of the drive we want to create, and the group if necessary. So when the script runs, it's basically going to identify what drive we can use. And it's going to call out to our VM system, and it's going to interrogate the system to find out what disks we have attached. Here in the example, I have SDA, SDB, and SDC. And we know SDA is being in use because it has a disk identifier. And we're going to check for that disk identifier to find out what drives are currently not in use. And for us, it'll be the SDB, the SDC, so on and so forth, okay? It could even be SDA, depending on how your system is configured. So once it figures out what drive we can use, it's going to call the correct file, the correct routine to create the type of drive. And we have three types of drive. We have regular drive with the file system on it, which I'm going to call a very unique name of drive. We have thin provisioning drives, which means that the storage allocation won't occur until it's needed. And we have the logical volume drive, which means that whenever we want to build a group, a bigger disk through a group of smaller disks, we can put them inside of a logical group and then treat each physical drive as a logical group and each logical group as a logical drive. It's easier done than said. But the third parameter here, that group, identifies what group we want to put these thin provision drives in, or the logical volume drives. And with both the thin provision and the logical drive setups, we'll be able to test whether or not the group is created. And if it isn't created, we'll create it and we'll put the drive inside of it. Any subsequent drives going for that targeted group will be added to it. So that's pretty much what we have in line today. Once we finish off our IP sync system, we're going to dive right into the storage system. We're going to begin by creating the VM add disk.shell script, and we're going to have a lot of fun. We're going to go pound some keys. Yeah! Hi folks, welcome back, and what we're going to do right now is we're going to clean up the sync IP issues that are still outstanding. A couple of things. When we wrote the scripts, I had put in a couple of log file entries as well as a temp file that we use to process the IP file. What we want to do is we want to clean up that temp file so that each time it runs, it removes itself so we don't fill up our temp directory. And we want to remove the log entry that every time it executes makes an entry inside of our messages catalog. And the reason why we want to do that is so that we don't fill things up too fast. So let's go ahead and do that, and we'll also work on the access to that share so that we don't have to be root in order to access it. So let's jump in with let me see, Vagrant file. Okay, or find out what the status is for our Vagrant VMs, and mine is up, so I'm going to jump into Vagrant and we're going to go into I'm just having one of those typing days here. Build prod. There we go. Okay, that was stupid. There we go. Alright, so now that we're in here, what I'm talking about, if we do an ls/temp, we'll see these files here, which is the Vagrant host file. And that Vagrant host file really should be cleaned up. It's coming from a temporary, it's created by the script as a temporary file. We need to clean it up. So I'm going to jump into root, and the reason why I'm going to actually work on this file here in root is because I really don't want to go through and reprovision the box just to clean this up. So what we have here is the first line of regen host file is our logger command. We want to go ahead and comment that out. This one fires every time the script is called. So we want to clean that one up, and we will come down to the bottom of the function, and at the bottom of the function, right underneath the CP, where we copy the file, we want to go ahead and do an rm -f $temp file. And that's all we need to do there. Now, as I said, I just modified the version on root, but that's not the version that gets installed when we do a provision. The version that gets installed when we do a provision of a VM box is out on our admin share. And right now we can't access the admin share except for root, and that's why I pulled root here. So let's go to media, SF, admin, and go ahead and work on the update host file .show. There we go. And again, we have our logger. We're going to turn that off. And then we're going to come down to the bottom. And typically what happens is that when I write these scripts, I only leave this stuff in for maybe a couple of hours and then go in and I clean up everything. And the reason being is because I don't want to leave them in a production script. So, and filling up your temp file is never, ever a good thing, as well as your log file. Okay, your file system gets too full because of logs and you wind up cleaning it up. Even though that will have processes to go out, check the log, do a rotation, things of that nature, but we're not there yet, so we need to be a little bit more careful. So that's the main thing to clean up here. Now, the second thing which we want to do is we want to add ourselves to the VirtualBox group, and what that will do is that'll give us the ability to access the share, the media SF admin share without having to be root. So to do that, we simply use usermod, and we're going to append, and we're going to use the group VirtualBox SF, and we're going to assign that to the Vagrant username. And that's all we have to do. Now we have to exit in order for that to take place. Let me see if there's anything else we wanted to do. We did the scripts. We had the group. I think we're pretty good. Great. Okay. Now, for this particular episode, we're going to manually add a bunch of disks. And the reason why we're adding these disks manually is because we want to be able to do the testing of the disk system, which we're about to write. But before I do that, I just remembered, good thing too. I'm going to call up my handy dandy editor. Okay, and here's my handy dandy editor. And I'm currently in my Vagrant file. And what I want to do is I want to come up here, and I just want to add one simple thing. Today's the 29th. Okay. And I want to say added Vagrant user to group to VirtualBox group for shares. Now, the reason why I'm adding it here is very simple. Every time we start up, we create a new box. We have a new user. So what we want to do is we want to make sure that we have access to that user or to the admin share via the Vagrant user. So what we're doing is we're doing the same thing which we just did out in VMbox. We're doing it here inside of a Vagrant file, so the next machine that we provision, it'll already be there. So VirtualBox SF, and our username is Vagrant. All right, so let's save that and get rid of it. Okay, so what I want you to do is call up your VirtualBox manager, the GUI manager, and what we're going to do is we're going to add disks to this unit, but right now it's running, so I'm just going to pop that to Vagrant, and I'm going to halt build prod. Okay. Now I'll call back up my should be shutting down any second now. And there it is. It's powered off. Okay. Now what I'm going to do is the build prod is the same build prod which we're using, or that was defined by our Vagrant file. This interface gives us access to do a bunch of configuration. So one of the things which we're going to do, we're going to go into settings. Then we're going to go to storage. I'm going to click on my IDE, my IDE controller, and I'm going to click right here where it says add storage attachment, and I'm going to add a hard disk. And we have 3 types of hard disks which we can add. And this is the hard disk type file, which covers the format for VM machines. For instance, the VDI is specific to VirtualBox. The VHD is specific to Microsoft's product for Virtual Manager. And VMDK is a VMware disk. So we're going to use the VMDK because that's what my current disk is. And we're just going to hit next. We're going to select a dynamic allocated disk. And for this, we're going to put this in our shared location. And for me, that was BDB dir share, which actually was mounted on the Media SF admin. So I'm going to come over here and I'm going to grab this. And the reason for doing that is fairly simple. We want to be able to access these disks from all of our VM machines if need be. And I'm to define this as a whole value. In other words, I'm going to select 4 megabytes to create this disk. And the reason why I'm creating it as 4 megabytes is because we're going to create a few of these simply for testing. And that's really what we're doing right here. And right here, another 4 megabytes. And we'll change the location of this to 2. Okay. And whoop. There we go. Create. Okay. And I'm going to add another controller. And reason being is because my IDE is limited to only 3, I think it is, disks. And I believe that's within the IDE protocol. So I'm going to create a SATA controller because I have a SATA controller. And I'm going to add yet another disk. And also, we're going to say that this is... I believe this is going to be 3. And we're going to make this 5 megabytes. And the reason why these are so small is because we're not going to put anything in them. Okay? We're mainly going to check to see the status of them and to make sure that we can identify when a new drive is there and when a drive is actually being used. So I'm going to add the last one here, and I'm going to make this 10 megabytes. So we got 2 4s, a 5, and a 10. And there we go. All right, so if I come back and I look at my settings and I look at my storage, I have 4 disks all defined. They're all VMware disks, I guess we can call them. And if we ever want to take a disk off of a VM machine and move it over to a VirtualBox, we should be able to do that, and vice versa. So, but I have no plans of doing that. But it's available if we want. Okay, so in any case, I just brought that down. Let's go ahead and bring up this box, Vagrant. Up, build prod. Okay, now when we bring up the box, the disk should automatically be defined for our VM machine. And we're going to go in, we're going to verify that, as well as to verify that we can access the share without having to become root, because we did that previously. So this should be up in about 2 seconds. And after we finish verifying the share and the fact that we have the disk, the new disk, we're going to go ahead and create a directory and start building this script. Okay, so let's do a vagrant SSH, and we'll say build prod. And what we have is, let's go ahead and see if we can see that admin share. Media SF admin. We can. In fact, I'm going to do an alias of ls. Turn off that annoying color. And we'll add symbols. So there we go. Now we can see that a lot better, I'm sure. So we just verified that we have the access to the share. And if we do an ls/dev/sd star, we can see that we now have a total of, let me see, we have SDA, we got B, C, D, and E, okay, which is our 4 disks which we just defined. So great, we're on a roll here. So let's go ahead and make a directory called storage. And let's go ahead and start defining the script. I'm going to touch a file. So I'm going to touch that file, and the file is going to be called vm add disk.shell. And I'm going to set the permission to execute automatically. There we go. And let's go into it. Bingo. And we will begin with our traditional shebang. And this is going to be VM add disk.shell. And this is going to take 3 parameters. It's going to take the size of the drive. It's going to take the type of the drive to create, and it's going to take a group. And this group will be the file group, the volume group that we're going to add the disk to if needed. So we have size, and this is the size of the disk. Then we have the type, and this is the type of drive we want to create. And then we have the group, and the group is the volume group of the drive. Now, let's talk about this type thing, okay? The value for types are going to be thin, and the thin type is to create a thin provisioned drive. And LV is to create a logical volume drive. And we're going to have just drive, for lack of a better word, which is a standard disk with a file system. Okay, so what we know about this is that we're going to take in 3 parameters per drive. Okay, so every drive that we want 3 of these. Okay, so we're going to say parameters. Okay, and we're going to say, for an example, like for thin group, or thin group, and we have a 5, so let's call that a logical volume, and let's say LV group. And these are actual parameters which we're passing in from our Vagrant file into our script when we do our provisioning. Okay, so this, and what I'm making up here is a series of these tuples that we're going to use in order to create our script here. Okay, so we know right now that we have a max args of 3. Okay, and we know our tuples are going to be disk size, and that's going to be in the first position. We're going to have disk type, which will be in the second position, and we'll have disk group, which will be in the third position. And so we really want all of our arguments to be a factor of 3. So let's go ahead and say, okay, what is it? $, pound sign. That's going to be the number of arguments passed into our script. And we're simply going to mod that by max args. I couldn't resist. In any case, some days I just crap myself up. Okay, so we're going to look at that args, and we're going to say if it's less than max args. Well, actually, we can simply do if $x is, well, no, we can't, because if somebody put in 0, that actually work. So let's do a less than $max args. So we're guaranteed at least 3 arguments when we run this script, okay? But if we get more than 3 arguments, it has to be a multiple of 3. And if we get a multiple of 3, then we're fine. If not, then we're going to call fatal. And fatal is one of those little functions I kind of use a lot. And the reason being is because it's so easy to handle errors. So here I'm just going to say not enough parameters passed. And I'm going to include all the parameters inside that list. And the reason being is because, you know what? When you're going between different packages, it's nice to have a little clue, you know. So we're going to put that there, and we're going to say echo error and $1, and then we're going to beat feet out of there, and we're going to throw the error message up. We're going to go to exit, just throwing our hands, you know, willy-nilly all around, going, I can't do it anymore. And we're going to die. All right, so moving on, you know. And a field separator is going to be set to a return. And then what we're going to do is we're going to process these arguments, okay? So we're just going to say, do a very simple loop, okay? I like to keep it simple. So while we have arguments, okay, all we're going to do is we're going to take, we're going to check the size first. And the only way that we can do the size is we need a counter here. CNT gets, this isn't Perl. Thank you. Okay, so CNT, just like we did above, modded by our max args, is going to tell us whether or not we can access the size parameter, which is right here in our tuple. Remember our tuple? And this is our size. So we definitely want to be able to know when we're at there, because we need to check it for a couple of things. We need to check to see that we have the proper value inside that argument. In other words, somebody can, throw us a fast one, and you know how people are. They'll go in, they'll modify a script. They may not know what they're doing. They could be like me, who knows? In any case, what this does is this is going to protect us from moving into it. And what we're going to do is we're just going to echo the argument into sed, and we're going to use sed to say, hey, does this argument have all numbers? And if it does, then we're good. Okay, we don't want to do anything. If it doesn't, we want to throw our hands up again, go waving around and say, hey, this is the end of this, okay? Because you're basically telling me that you have, other than, you have more things other than just numbers. And that to us is an absolute no-no. Okay, so all this does is says from the start to the end of the sequence of characters coming through sed, if it contains anything other than a 0 or 9, we're going to balk at it. And the way that we're going to balk at it is we're going to substitute that whole pattern. So whatever pattern it matches or doesn't match, more importantly, is going to be set right here. And what we're going to do is we're then going to say, okay, we're going to compare our results to num. And it's a fast and dirty test. And basically, if we don't come back with the word num, okay, then we know that there was alphabet. Could be alphabet, could be digit, punctuation, something's in there that we don't like. And we're just going to call our favorite routine fatal and say invalid disk size. And of course, we're going to give it our parameter, which we got. That way somebody can say, hey, well, this is what we got. And it's throwing its arms up and running away from us. Let's clean that up a little bit. Okay. So that's a quick and dirty way to do that. Now, the reason why we need this to be a number is because we need to calculate the actual physical size that we're going to get out of fdisk. See, fdisk is going to give us the full value, or what is it, the size in megabytes or gigabytes, the actual physical number there. So which is why we want to make sure that we go ahead and we CNT can multiply that to get the proper value, 1024, and raise that to the second power, and that gives us our value. Else, okay, because at this point, if we're right here, inside of here, after saying that, we wanted, the size, we got the size, so now we got to deal with these two arguments here, which is, just very simply, we're just going to say this And we're putting these all in an array here. And we give it $1. Now, that ends that. Now, the only thing which we need to do is we need to increment CNT, which is our counter. And we need to do a shift to get the next argument. And then we're done. Bingo. Isn't that beautiful? So what we have, we can go ahead and we can actually say echo disk array. Okay, and then we'll echo this. And what we have is we're just going to write out the entire array. Just kick it out. Okay. And that pretty much, you know, covers everything which we need right now. Okay. To see if this works. So let's see what we got here. So let's do a VM. Oh, I didn't pass enough parameters. All right, let's take one away. Still not enough parameters. Okay, so what was that last parameter supposed to be? Let's say none. How's that? And we still got that didn't work. Oh, that's horrible. All right, let's go in and find out what I screwed up on. Okay, and looking at this, I am saying that if it's less than, do I get a typo? Max args is not equal to 0. No. That's our problem. If the number of args is less than max args, okay, then we throw the error. Otherwise, if x is 0, yeah, we're fine. All right. Yeah. Almost sure. Let's take that away. Fine. Let's put it back. Bingo. All right. Well, it's progress. Okay. Uninspected NF file while looking for... Weren't you guys supposed to tell me when I miss a quote? Okay. So let me go in and find this missing quote here. Let me see. Invalid. Let me see. Okay, we got 2 quotes there. We got 2 quotes there. Here a quote, there a quote, everywhere a quote, quote. Let me see. Size quote. Okay. That looks good. That looks good. That does not. It's always the last thing, right? All right, so. And there we go. Okay, so we have our arguments in an array, and that looks perfect. Okay, so now what we really need to do, okay, what we really need to do is we need to identify what device this size goes with, okay? And whether or not that device is in use or not. And we only want to select it if it's not in use. In other words, it doesn't have, if we do this, if we do a sudo disk, fdisk, -L, and let's pipe that into grep, okay, and let's look for /dev, And then, let's see, how about, no, dis/dev. Is it dis? Yeah, that should do it. Okay, great. And it did. Okay. But as you notice, we have all these values here. Okay. But one of the things which we want to do is we want to make sure that this disk isn't in use. And to do that, what we can do is we can simply grep for disk identifier. Okay. So we know that something in there has a disk identifier. So if we go through and we say maybe like /dev/SDA, that has a disk identifier. But if we do one of the ones which we just created, like SDB, that doesn't. Okay, so we're going to use this to identify whether or not the drive is in use. Okay, so let's go ahead and let's create another loop which we're going to go through here. And we'll do the, let me see. Okay, so we want to loop through our drives here. So fdisk -L, and fdisk always throws a bunch of garbage out at us, so I'm going to mute it, and we can throw away this error because we're only doing read-only operations. It really isn't going to impact us, and that error message is really going to get into the way, so we're going to just move it out the way for now, and we're going to search for disdev like I did before, and we're going to exclude anything that has the word mapper in it. So dev mapper. Okay, actually, yeah, we'll leave it at dev mapper. That's fine. Okay. And what we can do is we can build an array, and the array which we want to build is going to come from this entry here. Where do we have it? Here we go. It's going to come from this entry, and basically we're going to feed it into awk. Okay, so what we're going to do is we're going to take the second parameter here, which is just the name of the device, and then we're going to take the size in bytes. Okay, and by taking the size in bytes, what we're doing is we're able to compare it to what we had, because remember we passed in just the 4 megabytes and we multiplied it by 1024 and raised to the second power. So we should come out with the exact same number, and if we don't, then two things are going to happen. One, we're not going to use that drive, and two, I'm going to buy a new computer. So, and since I'm not going to buy a new computer, it's going to come out right. So let's do this. Okay, so what we have is echo $I, not 1. Okay, and we're going to pipe this into awk. And we're going to say print, and we want to take the subster because we need to get rid of that annoying colon. So we're going to take the subster of $2, which is the second parameter. We're going to begin at the beginning. We're going to go to the length of it. So awk has a function called length. We're going to use that, and we're going to use that on our number 2, and then we're going to take away 1 character, and what that should give us, the proper device name without the colon. Okay, so, and then we're going to force a new line. And the new line is, we're forcing a new line simply so that we can turn entry into an array. Okay, so it's kind of a sleight of hand type of deal, but you know what? It works. So now that we have grabbed the last element that we needed, which was the actual physical size of that drive, we can pretty much now compare this entry here with our disk array here. Okay, so we want to use this whole disk array which we just built, okay, in order to find the matches that we need. Okay, so we're simply going to go into a for loop here, and we're going to call it diskEnt, and for loop, we're simply going to iterate through based upon the number of entries in our array. So as long as we are less than the number inside of our disk, and we'll give it the whole list, then what we're going to do is we're going to say diskEnt plus 3. Okay, so this is going to work as our mod for us. Now, all we have to do here is type good. That's never a given with me. But the first thing which we want to do is, because remember when I said that we're going to change this value here, which is our byte count, we're going to change our byte count to the actual physical device if we find a match. So if we do that, then any test we do for our first entry here, that's going to cause a problem. And the problem which it's going to cause is that we're going to have a case where we're expecting the size, we're expecting a number, and all of a sudden it's going to be a device name. So we're going to protect against that. So our first test, which we're going to do, is we're going to say if disk $diskEnt :0:4. So I'm taking the first 4 characters of this disk of the value inside of this array element, and value there, I'm going to compare that to /dev, and if it's not equal to that, woohoo, then we know that we have a number inside. But now the question then becomes, okay, is it the number that we want? Well, let's go find out, okay? And in order to do that, we're going to do another simple test, and we're going to use entry, and we're going to use the last element of the entry, because remember, we only have 2 values inside of there. We have the actual device name for the entry, and then we have the size of the entry. So we're going to compare size to size, you know, donuts to donuts, apples to apples, you know, ducks to ducks, you know, that way, you know, all of our ducks will be in a row. Wah, 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 wah. But in any case, all right, let's see, we want to compare that to our disk and our disk entry, because remember that disk entry is now representing a physical number. And then now what we want to do is, at this point, we know it doesn't have a device to it, so it's open to be assigned. 2, we know if we got this far that we found an entry inside of the array, and This array is the fdisk array. Okay, so we found an entry that says, hey, this is possibly not used. So what we have to do at this point in time is simply check to see if it has a disk identifier. Because if it doesn't have a disk identifier, that means that our drive is not in use. And therefore, we can abscond it. Okay? So let's go ahead and say not dollar fdisk minus L, and of course we're going to get rid of that annoying message that occasionally comes out. Let me see, but we want specifically the device of entry sub 0. And what that device is again, the device that we're testing, the one that we're saying that, hey, this is a possible match for us. So we're going to use that, okay? And then we're going to pipe this into grep, and we're going to check for disk identifier, lowercase. Okay. Yeah, sorry about that. Identifier. Okay. And that's pretty much well it for that test, okay? And let me see. I think I got a colon at the end. There we go. All right. And that should do that. So we have minus n fdisk minus L, the entry name, the device name, and we're going to do a minus L on that. So if it throws an error that has issues with something like cylinder, the number, it doesn't have cylinders defined, it's fine. Okay, we're going to come over here. We got the disk identifier. We're ending our test. Okay, so then, if all of that is true, what we want to do is we simply want to say disk sub dollar diskent, you guessed it, gets dollar entry sub 0, which represents the drive name. So now we have all of our missing components. We have the actual device which we're going to use for our drives. So we have that, and we're going to, let me see, that should pretty much do it. Okay. And yeah. So that's done. That's done. And let's verify it. So echo disk array, so that we can see, and we'll put a 2 there. I like 2s. Okay. And what we're going to do is we're going to do disk and at, and close that off. All right, so do I have anything dumb in there? Probably. Okay, but let's run it and let's see what we have to do. Now, when we run this now, we included the fdisk. So at this point, that's a privileged command. And in order to run that, we're going to have to run our script as sudo. So let's do sudo. Let's call up the old command. That way we have all the parameters on it. And we'll say sudo. And there we go. Okay, what we have is we replaced our byte count with a valid open drive, okay, which is the SDB, which we saw was the next one. And that SDB is 4 megabytes, okay? The same 4 megabytes that we passed in. We said 4 megabytes there. We looked at our disk array. It expanded it to 4 megabytes. And then we swapped that 4 megabytes for a drive that matched the 4 megabytes and was not in use. And we did the same for 5. Let me see. Okay, yep. Right down here, we said we're going to have a volume group of 5 megabytes. We can see that is 5 megabytes. And we come up here, and what disk is this? This is using DD. So DD is 5 megabytes. And the same with 10 for our last drive. And our last drive is 10 megabytes. Okay, so if we added one more disk, or better yet, let's change this and say, I want this to be, what do we got? Let's call it 15 megabytes. Okay, what we have is we can tell if we don't have any drives available simply by whether or not it has the device or the bytes. So, in our next episode, we'll be delving deeper into this script. We'll be modifying it to include, that type of check. And we're going to begin to define these different types of disks. So stay tuned. Hopefully you'll come back. I will see you again. I know that, you wanted to make my day by pressing that subscribe button, and I greatly appreciate it. So I will see you in the next episode. And remember, subscribe is everything. You will sleep so much better at night. I mean, it'll be like the best sleep you ever had in your life once you press that subscribe button. It'll be better than T-bone steak, honest. So I'll see you next time. Thank you very much. Bye-bye.